The quantum computing and quantum gates. Correct. So the moment we see the word quantum, it's kind of very minuscule or very minimum thing. Okay. So the most smallest one. So for example, the electron, proton, the nucleus, all of these things comes in quantum. And we already studied this in the class 11th, where we study about principal quantum number, azimuthal quantum number, spin quantum number, and all of these things. So it is basically calculating the energy level of the electron and how the movement of electron takes place, the momentum, the spin of the electron. But coming to the quantum computing and quantum gates, so the main application engineering, what we see mainly is through the application level, correct? So we know there are quantum computers, correct? Yes, which is starting maybe at around, I think the normal usage we won't be using, but there are computers which are starting around 3.5 or 4 lakhs. Okay, more than that of the Apple laptops or the Apple system. So quantum computing, so it's basically very fast. Correct. How do we achieve those processes? Correct. So we all know that one thing, let's see the laptop which I am using or whatever it is. There is a database, there is a memory, there's a RAM, ROM, everything, right? Correct. Ultimately, it is divided into what? Tables. Tables in the sense rows and columns. So especially the matrices part. Correct. Matrices part. So how do we achieve those things? Correct. How it is electronically programmed. So those things we'll be discussing in this chapter. There's a main practical application, but a 5 to 10% of that we will be discussing in this particular chapter, and how it is different from the old computing that is called the classical computing, and what is the quantum computing. Those differences also we'll see, but I'll be strictly going for the examination point of view only. But just to give you an idea, that's the reason I just an introduction part. I already told you it is basically for what, uh, very small level, the electron, proton, neutron, whatever it is. Correct. What is the behavior of these things? Correct. Now, quantum computation. Now we all know that the system will only understand machine level language. It is zeros and one. So almost all our matrices program will be based on zeros and one. But we will have complex numbers also, which is I. That is if it goes to the quasi state. So that will be explaining down the chapter. Now coming to the Moore's law, correct? Yes. So the Moore's law and its sense. So this is a very old thing. So this is basically, we can see the two graphs, right? Correct. We can see the two graphs. So Moore's law is basically a prediction graph. Okay. So where we apply this in semiconductor manufacturing chips. You got the point. Huh? So this is nothing but to set a targets for the R&D team and everything. It is nothing but the number of transistors in an integrated chip, IC chip, doubles about every 18 months. That is about the Moore's law. Now coming to the main differences, classical computing. Okay. In classical computing, we can only hold zeros and one. But in quantum computing, I told you, not only 0 and 1, if it goes to a state, quasi state in the sense, it cannot decide itself whether it is 0 and 1. That is, it goes to complex number also. Yes, and classical computing is basically what? Electrically, in the sense, voltage or current. Voltage or current. The bit information, the zeros and ones are stored on the bit information. But quantum, as I told you, it is based on electron spin configuration. Electron spin configuration. And obviously, classical computing, normal, our normal system, but this is basically quantum is high-speed computing. And again, we all studied about the classical computing like logical gates, correct, and or not and all. But in quantum computing, we'll be studying about X, Y, Z, H, and C naught gates. Okay. Yeah. And classical computing will give us the accurate value, whereas the quantum computing will give us the probable value. So which might be correct, which might not, because it's taking the very minute detail of it. And coming to this operations, if I want to tell addition, multiplication, everything, here we'll do addition, multiplication, normal, but not only normal, but we use in matrices. That's the reason it's fast. In matrices, so down the line of the chapter, we can see matrix multiplication. Okay, so we should read these things. They can ask for maybe 2 mark or 4 mark question. This one. Now, coming to bit. Concept of bit and qubit is there. Qubit is nothing but quantum bit. Okay, so which is quantum information stored. So bit is basically information. So which is mainly what zeros and ones respectively. That's all. And coming to the qubit. So I told you it's a quantum version of the bit, correct? And can be leveled as what? 0 and 1. 0 in the sense 1, 0. See the matrix representation here? Matrix representation is what? 0 is what? 1 and 0. And this 1 is what? 0 and 1 respectively. So this you have to know. 0 is represented as a matrix. The first one is 1, 0 and 1 is 0, 1. Superposition of the two states. Superposition in the sense I am adding 0 and 1. So alpha of 0 and beta of 1. Where alpha and beta are what? Complex numbers. So alpha square plus beta square is equal to 1. So alpha square is nothing, but I told you here in quantum physics, okay, we will be learning everything in what? Probability. Classical computing will get a definite value. In the quantum computing, we'll get only a probable value. So alpha square is nothing but probability of finding what? Psi. This is my psi in state 0. Beta square in state 1. So here, if they're giving this psi, this symbol psi is nothing but 1 by root 2 of 0 and 1 by root 2 of 1. So which means my alpha is 1 by root 2 and beta is 1 by root 2. So alpha square is equal to beta square is what? 1 by 2 whole square on both the sides. 1 by root 2 the whole square is 1 by 2. That's it. So 50%. So probability just like our half means what? We can just remember how to remember this? Just remember our probability of getting a head in the spin of a coin. 1 by 2. Probably getting a tail is what? 1 by 2. So 50% probability that it will be in 0 or 50% in 1. Properties. So qubits is important because they can ask in 8-mark question. This qubit. And again, it makes use of discrete energy. Discrete energy in the sense, discrete. So those who are taken computer science, in third semester, you will have something called discrete mathematics. Okay. So discrete math, so sets and all we already learned, right? In class 11th, sets, relation functions and all. So those are all discrete. In the sense, x, function of x, I'll write it down. So if I'm giving you f of x is equal to x square plus 1. This already we have seen. The function in relation function. This is nothing but discrete mathematics, where x can take a lot of values, correct? One function, one two function, all we have already studied. But now we don't remember it, but that's okay. But those are all discrete mathematics. So I'm just telling you what is the future. So future you'll be learning all of these things. Okay, even if you don't remember this thing, it's okay. It's just I'm just trying to explain the meaning of discrete. Okay, that's it. So qubits, that is quantum bits, you make use of discrete energy state, particles such as electrons and photons. Same thing, whatever I discussed, same thing is only properties. So it exists in what? Two quantums is 0 and 1 in linear combination of both states. This is not a superposition. Superposition means alpha of 0 plus beta of 1. Now coming to a 4-bit. See, obviously a bit register will be able to score which one? 2 power n or 2 power n. 2 power n in the sense, just 1 second. Yeah. 2 power n. So bit varies from 0 to 15. 10. 10 we will already, if you're learning C programming, we all know that 10 is what? A. 11 is B. 12 is C. Correct? Then D, E, and F. Only up to F we have. F is 15. Hexadecimal. 0 to 15. Correct? So 2 power n. If it is 4 bit, it will be 2 power 4. 4 bit, it will be 2 power 4. If it is 6 bit, it will be 2 power 6. If it is 7 bit, it will be 2 power 7. So it will be always on the base of 2 power 7. Suppose if it is 2 power 10, 2 power 10 is what? 1024. So if it is 2 power 5, 32. So I'm just telling you. So this will be on the base of only 2 power n. So how to remember this? Just remember the RAM. Correct? RAM in our phone. 2 GB, 4 GB, 8 GB, 16 GB, 32 GB. Correct? Or the memory card, 64 GB, 128 GB, 256 GB, 512 GB. All are in race of what? 2 power. Do we have any memory card with 300 GB? We don't have. That in the laptop, we can make a partition. But again, we cannot have a 300 GB sub. We can make a partition in the memory. That is a different thing altogether. We can allocate a space. But we can't design something with 300 GB properly. Okay. So all of these things are based on qubits, matrix representation. And now coming to, there is something called block sphere. That is state of the qubits. So here we got something called block sphere, right? The sphere you can see. That is nothing but state of the qubit is represented in block sphere. Okay, fine. So we got something called North Pole, correct? North Pole, which represent 0. Just see the diagram. No need to read the theory or anything. We can, seeing the diagram only, we'll be able to explain everything. Now I think you'll be able to hear. I think I muted myself. That might be the reason. Yeah, now I think it's audible. Perfect. So what I was telling is there are North Pole. North Pole is what? Represented as 0. That is spin up. South Pole is represented as 1. Spin down. And one more thing is R, theta, and phi. R, this is my phi. R, theta, and phi. R, theta, and phi will be my spherical coordinates. Will be my spherical coordinates. So they will just, if they ask you about representation of qubits by block sphere, mandatory way to draw a diagram. Correct? And you have to mention about these 3 things. Which one? The R, theta, and phi respectively. And same story. Psi is what? Alpha of 0 plus beta of 1. And if this represents 0 less than 5 less than 2 pi, which means our full circle is 360 degree. Correct? Our full circle is 360 degree. That only they are trying to mention. Alpha is the size equal alpha of 0 plus beta of 1. Now coming to this, it can be proved that psi is equal to cos of theta by 2 plus e power I psi into sine theta by 2. I sine into theta by 2. So this is my representation. Now case 1 is what? See, we got 0 degree, we got 90 degree, we got what 180 degree, 270, 360. Correct? 0, 90, 180, 270 and 360 degree is there. Correct? Now, if I'm putting theta is equal to 0 here, what is cos 0 value? If I'm putting theta is equal to 0, what is cos 0 value? 1. Cos 0 value is 1. And here, sin 0 is what? Sin 0 is 0. Sin 0 is 0. So this full term is 0. First case is theta is equal to 0. So I'll be getting psi is equal to what? 0. Second case, if I'm putting theta is equal to pi degree, 180, and phi is equal to 0. Phi is always 0. Pi is, theta is equal to pi. Theta is equal to pi. What is cos 90? Cos 90 is 0. So this full term is 0. What is sin 90? 1. 1 into 1 is 1. So I'll be getting psi is equal to 1. Okay, I'll just zoom this thing. I think now it will be kind of clear. First thing is theta is 0. Theta is 0 means what? Cos 0. Cos 0 is 1. Sin 0 is 0. So this is 0. I'll be getting 0 plus this is 0. Theta is equal to pi. Correct? So pi by 2. Pi by 2, what is cos 90? 0. So this full term is 0. Gone. And sin 90 is what? 1. And phi is 0. So e power 0. E power 0 is what? 1. Anything power 0 is 1. Anything power 0 is 1. Next case is theta is equal to pi by 2. Next case is theta is equal to pi by 2. So again in the top equation, again in the top equation, I'm going to put what? One minute, just give me a minute. Yeah, so coming back to the class, I'm just only substituting all of these values in this equation. Which one? Psi. Cos theta by 2 of 0 plus e power I5 sin theta by 2. Simple things only. All of these things are. So if theta is nothing but pi by 2. If it is pi by 2, it will become what? Cos pi by 4. What is cos 45? 1 by root 2. Sin pi by 4 is 1 by root 2. So I'll be getting here 0 plus 1 by root 2. Just add these things. 0 plus 1 by root 2. That's all. If theta is equal to pi by 2 and phi is equal to pi, e power I pi. So this you can do it in calculator and check. E power I pi will be getting -1 answer. So this sign only will be changing. This will be minus stage. Okay, so I'm getting the same thing 0 minus 1 by root 2. If theta is equal to pi by 2 and phi is equal to pi. So this is nothing but represents a single qubit state. Now multiple cubic state in the sense there are two qubit values 0, 0, 0, 1, 1, 0 and 1, 1 respectively. 0, 0. The first one will be 1, then followed by 3, 0, 0, 1. The first one will be 0 followed by 1 and 2 0 values. Just shift the 1 places. That's it. Just shift the places of 1. That's the only way you can remember. For 2 qubit system, we have 4 complex altitudes. That is alpha square plus, that is alpha 0 0 square plus alpha 0 1 square plus alpha 1 0 square plus alpha 1 1 square is equal to 1. Okay. Now coming to this is nothing but my summation form where the superposition that I have mentioned earlier, right? The addition of alpha of 0 plus beta of 1. Correct? That same thing is if there are 2 power n complex amplitudes. If there are 2 power n complex altitudes, then see, for example, if it is hexadecimal, hexadecimal is what, 16. Hexadecimal is 16, but we'll be only doing 0 to 15, right? How I'm getting 16? Basically, 16 minus 1 is 15. So suppose there are 2 power n amplitude. How will I get this 15? Nothing, just do 2 power n minus 1. So 16 minus 1 is 15. So that's how I get 0 to 15. So the same thing only I'm putting here also. And this you have to by heart and keep. Suppose if you don't understand, I'll help you out once the class is over. Yeah. So coming to the Dirac representation, the matrix operation. Okay. So there is a notation. See, the 0 and the 1, correct? We had that notation, right? I think let's come back to this. Yeah, I think you can see the notations here, especially the 0 and the 1, the notation here. So the notation has got a name, correct? So normally we don't pronounce this name, we just say zeros and 1. But since just to know for the notation, this is called ket notation. Okay. And the one with the less than symbol, this is called bra notation. So these together are called what? Dirac notations respectively. Ket as well as bra notation. Two notations are there for representing what? The matrix respectively. Okay. Now coming to my psi, this psi, correct? If it is representing with this is what ket. So this is an example of ket vector. Ket vector. Suppose if the object is a vector, it is a ket vector. So if suppose the object is scalar, then it is what? Ket scalar represented. So ket scalars and all you don't have as of now. Maybe in the future you'll have it. But if you're computer science students, you won't get it. Okay. And psi, we already have discussed in the first chapter. Psi is the wave function. Correct. So psi is nothing but alpha and beta. So this is my ket psi. Alpha of what? 0 plus beta of 1. Because I'm not going to say about the ket or the bra notation here or the Dirac notation. I'll be just telling about it is a what? Alpha of 0 or beta of 1 represent. Correct. Now coming to this, yeah. The matrix of the following things. 0, we all know it is 1, 0. 1, it is 0, 1. Correct. So this is kind of what this ket vector is represented as what? Column. If you don't know what is a row and column, if I'm putting here 1, 0, correct? This is my first row, this is my second row, this is my column 1. So my ket notation will be what? Always in column. The other one will be always in row respectively. That's all. The other one will be always in row respectively. ROW. Okay. The other notation. Identity matrix. Okay. Identity matrix is 1, 0, 0, 1. So obviously in either of the notation, there won't be any change. So I of 0 is 0, I of 1 is 1. 0 means just remember always you have to put 1 on the A11 column. A11. That is first row, first column. It should be 1. Correct? Second row, first column should be 0. The otherwise, square matrix. Conjugate matrix. Conjugate matrix in the sense, if A is nothing but 0, I and minus I comma 0, A star is what? 0 minus I comma 0. In the sense, conjugate in the sense I'm just changing the signs. I'll write down here, change the signs. Minus will become plus and plus will become minus. That's all. Minus will become plus and plus will become a star. Change the signs. That's all. And change the signs of what? Only the complex number. Only the complex number. Iota. Complex I. Complex number only we will change. Don't change the sign of ones. Only the I. Clear? Transpose matrices. So converting rows into column and column to rows. That's it. 0, 1. 0, 1 is what? Row. That will be converted into column. That's it. Rows into column and column into 1. Hermitian matrix is nothing but I'll be taking the transpose, but as well as I'll be taking what? The complex conjugate. In the sense, convert this into transpose, correct? As well as I'll be taking what? The complex conjugate. So first thing is, I'm taking the conjugate, A star. So wherever I is there, I'll put minus value. Done. Then convert row into column. That's it. Convert row into column. Simple as that. It is as easy as it sounds. Okay. Okay. Unitary matrix is nothing but we all have studied this also in the lower classes. What is my A dot A inverse? I. Correct? Yes. A dot A inverse is what? I. Yes or no? A dot A inverse is nothing but my I. So what is my A inverse? I by A. I by A. A inverse from this is what? I by this A will come down. I by A. That same thing only this is also. Okay. So with this we can show that this is there. But I just wanted to know what is unitary matrix. That's all. From my end. So column matrix is ket. This is my ket. The other one is, you know it. The row matrix. Okay. So obviously the ket is the complex conjugate of the other matrix and vice versa respectively. Let's see one question. Find the inner product of u is 3 plus I and 4 minus I and v is 3I and 4. So first thing is 3 plus I and 4 minus I. So first thing is take what? The conjugate. So plus I will become minus I. I'll write it down here. This plus I will be, this signs will be changed. Signs are changed. Then take transpose. Transpose is done. Correct? Yes. Transpose is done. Then u into v. Multiply this into this. So first row element multiplied with the first. So 3 minus I into 3I. 4 plus I into 4. Just use